Welcome to qnawire.
Hi, so for the first question, question 5, we have sodium carbonate with 10 molecules of water as hydration, and we're asked how much of it can dissolve in a 1 liter solution of zero point 0.1 molar calcium 2 plus before we see any calcium carbonate precipitate. So first of all, the information that we need is the solubility product of calcium carbonate. Remember that this is going to be equal to the concentration of calcium 2 plus times the concentration of carbonate 2 minus. This value is this value is 1.4 times 10 to the minus 8. This is a constant that you can find. And sometimes they give you different values depending on the table that you're using. So if the professor gave you a specific one or is using one from a certain book, you should plug in here that value. Okay? So this means that the concentration of calcium 2 plus times the concentration of carbonate is to be equal to this number. Thus, the concentration of carbonate that we are going to be able to have before any precipitate forms, it is going to be equal to 1.4 times 10 to the minus 8 divided by the concentration of calcium 2 plus. In this case, this concentration corresponds to zero point 0.1 molar. So the result is going to be 1.4 times 10 to the minus 7 molar concentration. Okay, so next up, what we need to get is the amount of grams of the sodium carbonate that is hydrated that correspond to this concentration. So in order to do this, we're going to start with our concentration, molar of CO3, 2 plus. Remember that this means moles of CO3 per liter of solution. We know that the relationship in between 1 mole of CO3 2 minus and the sodium carbonate is a 1-to-1 relationship. And here we need to take into account the waters of hydration that we have. And next up, we are going to transform this into grams. So 1 mole of the sodium carbonate 10 times hydrated corresponds to a certain amount of grams of this compound. Na2 carbonate 10 times hydrated. That amount of grams is the sum of the molecular weight of the sodium carbonate plus 10 times the molecular weight of water. So this corresponds to the molar mass and is 286.14 grams per mole. After doing this operation, as you can see, the result that we're going to get are grams that are admitted per liter of solution. And since we have 1 liter of solution to begin with, then those grams are directly the amount that is asked of us. So this is 4.006 times 10 to the minus 5 grams of my sodium carbonate, 10 times hydrated. Now, for the next question that we have, we want to get the delta G. So, question 6. We want to get the delta G naught for the reaction iron 2O3, so ferrous oxide, plus 2 equivalents of aluminum. It's going to produce aluminum oxide plus 2 equivalents of iron salt. So remember that delta G naught of reaction is equal to the sum of the delta G's of the products minus the sum of the delta G's of the reactants, and each of them needs to be multiplied by the stoichiometric coefficient. So this would be delta 2 times delta G of formation of iron solid plus delta G, of course not for all of them, delta G of formation of aluminum oxide as a solid minus delta G of formation of iron oxide minus 2 times delta G of formation of aluminum solid. Luckily for us, here we have two substances in their standard state, so delta G of formation is equal to 0, and delta G for the reaction becomes delta G naught of formation of aluminum oxide as a solid minus delta G naught of formation of iron 2O3. So I'm going to use the values found in Overby and Chang's book in the 13th edition, but again, you should use the values that are provided by your professor or the values that are given to you in tables or whatever source you're using in this case. So the value for delta G naught of formation of aluminum oxide is 1576.4 kilojoules per mole, and the value for iron oxide turns out to be minus 741.0 kilojoules per mole. So our final answer is going to be minus 835.4 kilojoules per mole. So delta G naught of the reaction is lower than 0. That means that the reaction is spontaneous and it is going to be favored under standard condition. Another way to justify this is remember that delta G naught is equal to minus RT logarithm of the equilibrium constant. So the equilibrium constant is going to be equal to the exponential of minus delta G naught divided by RT. R and T are positive numbers. Delta G in this case is going to be negative, so that means that K is going to be much larger than 1. So the reaction is going to be spontaneous for all temperatures. And that would be all. Thank you very much.